Given a polynomial and one of its factors, find the remaining factors of the polynomial. Okay, here I have my polynomial, 6x cubic minus 25x squared plus 2x plus 8. And here I have my factor. Okay, the polynomial is cubic. Okay, so I have two missing factors. What are you supposed to do? The process is synthetic substitution. Okay, for the synthetic division process, first I need to check if I have every single position that's needed. The highest exponent is the power of 3, so we need the power of 3, power of 2, power of 1, and the constant term. We're good. Okay, I'm going to take away the coefficients. 6, negative 25, 2, and 8. Okay, I'm going to use synthetic division. And for the synthetic division process, I'm going to use that factor. Okay, I know this is a factor. So if I use synthetic substitution, the remainder is supposed to be 0. Okay, but first I need to isolate the x. 2x plus 1 equals 0. 2x equals negative 1. Divide by 2 on both sides of the equation. And x equals negative 1/2. So for the synthetic division process, we're using negative 1/2. Step 1, bring down the 6. 6 times negative 1/2 is negative 3. Negative 25 minus 3 is negative 28. Okay, negative 28 times negative 1/2 is positive 14. 14 plus 2, 16. Then 16 times negative 1/2, negative 8. And bingo. Okay, the 0 that we already talked about. Okay, but remember the instructions. We need to find the other factors. How we can find those other factors? By creating a polynomial with the numbers that we see right here. Remember, every time you do synthetic division, the original polynomial goes down by 1 degree. My original polynomial is cubic, so after the synthetic division process, my new polynomial is square. Okay, so I need to find that polynomial. 6x to the power of 2 minus 28x plus 16. Now we're going to check for factorization. But before the factorization process, if you analyze the polynomial, okay, we can see that it has a GCF. So I'm going to take away the GCF. The GCF is 2. If I divide everything by 2, what's left? 3x squared, okay, minus 14x plus 8. Now we can factorize the polynomial. Because a is not 1, the factorization process is the trick. 3x, 3x, everything divided by 3. 3 times 8 is 24. Okay, add the symbols. First one goes down exactly as it is. The second one is a multiplication of the two original symbols. And now I need factors of 24, that after I add my factors, the answer is 14. Of course, factors are 12 and 2. But that is not my final answer. Okay, that factorization is incomplete. We need to cancel the 3. If you analyze the first parenthesis, we realize that is divisible by 3. And that is exactly the number that we want to cancel out. If I divide the first parenthesis by 3, what's left? X minus 4. Second parenthesis stays the same. And voila, those are my missing factors. Okay, the missing factors are x minus 4, 3x minus 2. Okay, and if you put it together, all of the factors is 2x plus 1, x minus 4, and 3x minus 2. That is the complete factorization of the original polynomial.